So the next transformation we're looking at are rotations. So remember, rotation is basically when a figure turns, and it's when it turns about a specific point that we call the center of rotation. So let me write this down. There you go. So again, it's where a figure is turned about a specific point, which we call the center of rotation. So if you take a look at this picture on the right, this point Z right here, this is what we call the center of rotation. So if you can almost imagine it as if, you put this quadrilateral on the edge of, on the pencil point of your compass, right? Um, and you were, just spinning around your paper, the point where your compass point is, that would be the center of rotation, right? And then that quadrilateral going around that point is the quadrilateral being rotated. Okay? Something else to think about is this specific angle. This angle is called the angle of rotation. The angle of rotation is when you map the distance from the center of rotation to the pre-image point and then to its image point. And this creates what we call, again, the angle of rotation. You need to know that angle of rotation, otherwise you don't know where to stop spinning. So that angle of rotation and center of rotation are two things we definitely need to perform this transformation. Unless otherwise noted, we're always going counterclockwise. Okay, so again, unless otherwise noted, we're turning to the left. And we're going to do rotations in two ways. So we're going to do this part in class where we're going to draw the rotation using a compass and protractor. And then in the video today, we are going to look at coordinate plane rotations that go about the origin. So what this means is 0, 0 is that center of rotation. Okay? So rather than have us figure out, the rules, let me go ahead and just give them to you this time. So 90 degrees, meaning 90 degrees to the left, what we're going to do is we're going to take the point AB, or XY, however you want to think about it, and we're going to rewrite it as the opposite of B, comma, A, or the opposite of the X value, or sorry, the Y value, comma, the X value. Okay? Rotation 180 degrees is when we do the opposite of A and the opposite of B. Remember, again, negative means opposite, not just negative number. And then 270 to the left is when we flip the order and we keep B the same and make A the opposite. All right? Now each counterclockwise rotation maps to a specific clockwise rotation because we're going in a full circle. So that's just something to think about when you look at the directions. If it specifically says, 90 degrees counterclockwise, you want to think, well, how many is that clockwise? Or vice versa, right? If I said rotate this 270 degrees clockwise, you want to think, well, what is that rotation rule counterclockwise? So remember, the whole thing has to add up to 360. So if we went 90 to the left, we're basically going 270 to the right. So 270 clockwise is the same thing as 90 counterclockwise. 180 clockwise and counterclockwise, the same because that's 1/2 of 360. And then 270 counterclockwise is the same thing as going 3/4 of the way to a full circle, and we have a remaining 90 to go. So that's 90 degrees clockwise. So just something to keep in mind if you ever see that in directions. Okay, so let's take a look at example 2. And what I want to do is I want to take this pre-image, this quadrilateral R, S, T, and U, and I want to rotate it 270 degrees about the origin. So let me go ahead and draw my pre-image first, being very careful, especially when the grid is so small. We want to make sure we don't misplot. And I actually tend to do that when my graph is tiny, so that's why I'm just taking my time with this. All right, so there's my R, S, T, U. Probably should have, let me fix this R. Put that R on top so it's a little easier to see. And there we go. All right, all fixed. So R, S, T, and U. So we want to go 270 degrees about the origin. Remember, unless otherwise noted, we're going counterclockwise. So this means we're going to the left. So what I want to do is I want to use that rule. I'm going to take my a and b, or if you want to go x and y, we're going to transform it to y negative x or b negative a, right? B the opposite of a, y the opposite of x. And I actually prefer to write out all my points, and I'm so used to starting with a. Let me back up again. We're looking at r prime, s prime, t prime, and u prime. So I'm going to apply the rule. So 3, 1 turns into 1, comma, negative 3. 5, 1 turns into 1, comma, negative 5. 5, negative 3 turns into negative 3, comma, 5. 2, negative 1 turns into negative 1, comma, negative 2. Sorry, that should have been a negative 5 there. Okay? And then let's go ahead and graph and label your points. So 1, negative 3 is my r prime. 1, negative 5 is my s prime. T prime is negative 3, negative 5. Oh, let me move my r prime label out of the way. Let's put that over here. All right, so negative 3, negative 5. That's going to be my s prime. Or no, I'm t prime. Sorry. This is what happens when Miss Huang makes a video at 9 p.m. at night, guys. All right, so t prime, and then u prime is at negative 1, negative 2. So there is my shape. So you see how it's churning, right? It's not oriented in the same way. It's still an isometry. It's still a rigid motion. So it's still congruent, but it's turning, right? We're turning around that 0, 0. If I want 90 degrees again, I would go right back on top of it, and that'd be 360. Okay, so that's a rotation. Okay, so we're going to stop right here. I'm going to have a few more questions for you guys to answer before we finish off the Edpuzzle video. Um, and then we'll finish off the notes with rotational symmetry, looking at how to use a compass and protractor to do the rotation. So bring your compass to class and go from there. All right, thanks for listening. Come back with questions.